Okay, so now we know the rules of Sudoku, let's have a look at a basic strategy. And we're going to start by looking at the simplest of strategies, which is to eliminate all known values. Okay, so let's have a look at a strategy to try and work out the missing numbers from the unknown cells in this board. As we look down this particular column here, we can see that in this column we've got 3 numbers missing. So we know in these cells here must be the numbers that are missing out of this particular column. Now when we come to look at doing this in a computer, what we'll probably do is we'll put all the possible numbers that could go in this cell in the cell. So we'd put the numbers 1 to 9 in this cell, and we put the numbers 1 to 9 in this cell, and we put the numbers 1 to 9 in this cell. We then look down the particular column and we say, well, in this cell here, let me have a look what known cells there are in this particular column. So we've already got a 6, an 8, a 1, a 7, a 5 and a 9, so they can't be in any of these 3 cells, and we cross those numbers out. The result of this would be, looking down this particular column here, that we'd end up with just 3 possible numbers in these 3 cells. So what are they? Well, we've got the number 1, 2 is missing, so that could be in any of the cells. If you scan down, you'll also see 3 is missing, so that might be in the cell. And if you scan down again, you'll see 4 is missing, so that might be in the cell. So we call these known cells because we know the number in them. We call these unknown cells because we don't yet know what number actually belongs in there, but we do know it's either a 2, a 3 or a 4 in each of these cells. We now look to ways to eliminate those possibilities. Well, we look down the column initially, so now we need to look across the row. As you can see in this row across here, we already have a 4, so 4 can't be in that cell, so I can remove the 4. If I look across this particular row here, 2, 3 or 4, that doesn't exist, so that's still a possibility. And if I look across this row here, we already have a 3, so it can't be a 3. We then check each square. In this square here we have 5, 9 or 7, so that's not going to help us. And in this square here we have 5, 9, 3 or 7. Well, we've already got rid of the 3 anyway, so that only leaves us those 2 numbers. So starting with, we've narrowed it down. In this particular cell it's either a 2 or a 3, in this one it's a 2, 3 or 4, and in this one it's a 2 or a 4. And clearly as we work out what belongs in these cells, we'll be able to eliminate them from the other cells in that particular column. So that one didn't help us. Let's have a look at a row where it's a bit easier. Let's have a look at this particular row here. In this particular row here we've got 1, 2, 3, 4 missing numbers. So again, in the computer program we'd probably fill each cell with the numbers 1 through 9, and then we go and eliminate 6, 3, 2, 4 and 8 from each of those cells. So it just leaves ourselves with the missing numbers. What are the missing numbers? Well, a 1 is missing, 2 we've got, 3 we've got, 4 we've got, 5, I can't see a 5 anywhere, 6, got a 6, 7 is missing, looking down again, 8 I've got, and a 9. So my missing numbers are 1, 5, 7 and 9. So that could be a 1, 5, 7 or 9. That could be a 1, 5, 7 or 9. And this could be a 1, 5, 7 or 9. Okay, we now look to each of those cells to see what we can eliminate. So looking across the particular row here, we've already got a 9, so that can go. And while we're here, we'll look within the square, we've already got a 1, so that can go. So that's a 5 or a 7. Here, looking across here, we don't know whether this is a 2 or a 3, so we can't use that at the moment. We've got an 8 and 4 and a 9, so it can't be the 9. Here we've got a 5 and a 7 and a 1. 5, 7, 1. So all these 3 go, which means that one must be a 9. And if we look across this bottom particular row here, we've got a 1, it can't be a 1. We've got a 5, can't be a 5. We've got a 9, can't be a 9. 7 is the only remaining one, so it must be a 7. So what we've been able to do now in this particular row is know that that bottom cell there must be a 7, and that cell there must be a 9. Now we know in this particular row that 9 and 7 have gone. We can cross out the 7 there, and we can cross out the 7 there, leaving us only, well, in this top cell here we'd already got 1, so 5 was the only remaining number. So we can cross it out because it must be a 5 in there, so we can cross out the 5 in there, which means it must be a 1 in there. And we've now solved that particular column. It may be that we couldn't have solved that column straight off, and we'd have to go and look at the other columns and the other rows and the other squares and just try and go around using a process of elimination. But using this type of approach we can solve a lot of the simple and easy Sudoku problems. Hope that made sense. Okay, because I've got these numbers now, I'm just going to write them out in pen just to make sure that we don't lose them. So I know that that is definitely a 5, I know that's definitely a 1, I know that's definitely a 9, and I know that's definitely a 7. So they are now our 4 new known cells. Okay, so this would be really boring to watch if you watch it really slowly, so I think we're going to speed things up a bit, and you're going to see this in QuickTime. Okay, just one last little thing to do then. Looking up here on the top row, I've got a 2, 3, 8 here. Well, we've already got the 3 over here, so it can't be the 3, which leaves me just 2 and 8. And in here I've got 2 and 8. Just a quick check. No, I've got nowhere 2 and 8 in the square. I've no 2 and 8 in the column, in the row, and I've no 2 and 8. So these are an unknown. So I'm just going to clear up the grid now and put our actual known numbers there. Three, 7, 5, 4. Seven, 9, 2 and 8. 2 and an 8, 2 and an 8. That was a 3, and that was a 1. And that one was a 5. Okay, so we're at the last one now. We're going to make our life a bit easier. Rather than now go across the grid, even though this is what we would do in the computer, we would still just carry on processing that particular row, then that particular row, and that particular row. As we can see now, as we look down our columns here, we've actually got a lot less unknown cells as we come down. So what we're going to do is we're just going to switch the processing round. And when we're writing this as a computer program, what we would actually do is we would run through probably all the columns first of all, and then we would run through all the rows first of all, and then we would run through all the columns, and then we might run through all the squares. Whether we're doing a particular row or a particular column or a particular grid, it's essentially the same process. We're just looking within that particular group of squares, whether it's a group of 9 across, a group of 9 down, or a group of 9 in a square. We're applying the same sets of rules. So this will be quite a good application of kind of generalization. Doesn't matter whether we're really looking at a column, whether we're looking at a row, or whether we're looking at a square, it'll be the same rules. So let's have a look at this particular column here now. Well, we've got 2 unknown cells. What are they? Well, I've got 1, 2, 3, 4, 5. I can't see a 6. I've got a 7 and I've got a 9. So it looks like 6 and 8 seem to be missing. So I've got a 6 or an 8 in those 2 cells there. Voila, done. Okay, quick check, make sure everything is okay. Just within any particular square now. 1, 2, 3, 4, 5, 6, 7, 8, 9, that looks good. 1, 2, 3, 4, 5, 6, 7, 8, 9, that looks good. Pick any particular column. 1, 2, 3, 4, 5, 6, 7, 8, 9, that looks good. Pick any particular row. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so yeah, it certainly looks good. That looks like we've completed the Sudoku puzzle. Now, obviously this one worked fairly easily. It may be that we've got to go back and do those iterations several times, but essentially all we're doing each time is we're looking at a particular cell. If it's an unknown cell where we've got several unknown numbers in there, then what we need to do is have a look in the row to which it belongs, the column to which it belongs, and the square to which it belongs, and see if we've got any known cells in there, and we can eliminate those from the unknown cell. And that process will solve a lot of Sudoku type problems.